90-degree perpendicular to both of them, right? We will use this fact a lot in complex numbers and coordinate geometry, obviously, and here also a little bit, maybe not much here. Okay. So basically, let's say 90-degree perpendicular to both of them, right? We will use this fact a lot in complex numbers and coordinate geometry, obviously, and here also a little bit, maybe not much here. Okay. So basically, let's say you are having this Q line, and this is the equation of the line that they want. Okay. So since it is perpendicular to both of them, that means it is parallel to the cross product of both of them direction ratios. So just have to do one thing actually. You can write, let this be P point, let this be Q point. You have to find these points, right? How can you find that? By using the point of intersection, right? And how do you find? Let's say you're given two skew lines. You have to find the equation of line along which the shortest distance is formed. So how can you find?
Okay, we have two skew lines, and we have to find the shortest. We have to find the points where the shortest.
No, equation of line.
Formed.
Yeah, same thing. Yeah.
Okay, wait. I'll come again. We just we have to find the equation.
How do you find P and Q? P and Q are the points.
Okay, give me 1 second to think about it. We can just you can just, isn't it just okay? No, that wouldn't work.
See, what you do is this P point would be lying on the first skew line. Let's say this is lying on the second skew line. Take a point, random point to this line. How? By using parametric coordinates, right?
Yeah.
And then similarly for this also, write QP. That should be parallel to this B1 cross B2. So comparing the coefficients, right? This by this is equal to this by this. Yeah? Basically, A1 by A2 is B1 by B2 is C1 by C2, like that.
Oh, okay, got it. Yeah. And then.
Okay.
Yeah.
Now distance of a point, last concept, from a line along a given direction. So this we did in straight lines also. Let's say we are having this I plus j plus k plus lambda times 2i minus k, and this is some point 0, 0, 0. We have to find distance between this point and this line along the line whose direction ratios are I plus, basically this is the direction ratio vector. So that means we have the point, we have the direction ratio, right? What you can do is a lot of ways you can do actually. You can write the equation of this complete line, take the point of intersection of this line, find this point, and write PQ, right? You would have your answer. But a better way to do is actually call this thing as L, okay? And now your L can be written as, okay, right? Take that thing as L. Now write the unit vector. So how to write the unit vector? So basically the distance is L and the direction is given by I plus j plus k. So it would be, because it's magnitude times the direction. So L times I plus j plus k upon root 3, right? Now this thing should satisfy what? It should satisfy this line.
Yeah.
So a better way to do this, kind of, write this in the Cartesian coordinates. So x minus 1 equals to 2, y minus 1 by 0, and z minus 1 by minus 1. Now put this thing here and solve for L. Okay. Also, one more thing. Tell me one thing. This thing, the way that we have written Q, when we had a point P known and the direction ratio known to us, is something I told you in the very beginning when we started the equation of line. How to write it? This way out.
Yeah.
Correct? Yeah. P vector, which was a point known to us, 0, 0, 0, plus. Now see here we were trying to find plus minus 2 at a plus minus 2 distance, above and below, but there is just L, right? And it's below, so you can take that as positive or take that as negative, it's your choice. And this is unit vector along B. Okay. So this completes this chapter. Only this much is required. Yeah,
Okay.
I can give you 2 homework questions actually.
Mm-hmm.
So first question is angle between 2 diagonals of a cube. Okay, and the second question is, let's say a line is making theta 1, theta 2, theta 3, theta 4 angles with 4 diagonals of a cube. Then you have to find value of cos square theta 1 plus cos square theta 2 plus cos square theta 3 plus cos square theta 4. Okay.
I can do them now too. I've done a few questions like this before.
Okay, so you can, if you have done so, you can skip. We have a little less time, so I'll start with vectors. You can do this one till if you want, or whatever one which you're not doing.
Yeah. We just take cos theta equal to AB by mod A mod B, right? And then minus 1 plus 1 plus 1 by 2 3 root 3 equal to 1 by 3. So theta equal to per cos 1 by 3. I don't remember the exact value, but it's something like that.
Yes, correct. Theta is cosinus inverse.
Yeah.
Basically, best is to make this thing and consider a random cube. I mean, it's not made properly, so consider an actual cube and make it lie along the, let's say, make it lie along the x-axis, y-axis, z-axis. Consider these points. Let's say this origin. Let's say, so this would be what? Let's say the side length is 1 unit, right? Which is the magnitude of that basically. Let's say this would be 1 comma 0 comma 0 like that, and basically find all the points and find the diagonals. Okay, now vectors. So basic things, PQ, right? This is final, this is initial. You always write it like terminal, which is final, minus initial. So here the terminal is Q, so you'll write that as OQ vector. O is the origin, minus OP vector. Correct or wrong?
We have,
Correct.
yeah.
And also here also you would have the section formula, right? Same thing, MB plus NA
Yeah.
upon M, right? For external division you can write it. Okay, then let's say A vector is here, so minus A vector would be here, right? 2A vector would be the double length of this, right? It does not look like double, but this is double. Okay. Let's say you have a vector which has components ax, ay, az, and this one has bx, by, bz. How to say if they are parallel? So ax by bx should be ay by by. That should be az by bz. Okay. What about collinear points now? So let's say you're having A, which is position vector A vector, B vector. Also, it's best to assume position vectors, right? Take one point as origin and write the other vertices as position vectors. If some polygon is given, it's like that. Very useful. Without the laws of generality, you will do that. So, see, if these are collinear points, that means AB should be parallel to BC. So you can take the direction ratios and compare
Yeah.
it, right? Using this thing. So this was told in straight line also. Now you know this thing. When generally we don't work with magnitude, we always square it. So that's why we are squaring, because we have to get rid of the square roots. That is a square plus b square plus 2ab cos theta. You can write this thing as 2a dot b. Similarly for a minus b square and everything. Okay.
Mm-hmm.
Now are you aware of parallelogram law, triangle law, and polygon law of vector addition? Let me show it. Let me show to you the parallelogram law. Let's say we have b vector over here, a vector over here. This is forming a parallelogram. Let's say this is one of the diagonals. So this would be a vector plus b vector. Right. And this would be what? A vector. We can write it as b vector minus a vector. Basically, a triangle law. Let's say a vector is here, b vector is here. So now the C vector would be here. So you can say C vector is A vector plus B vector. This is the triangle law. So the C vector is opposing the direction of basically any one of the vectors which is opposing the direction of the other two vectors. You take that as the LHS, and I mean whatever you want to write the equation, but that vector should be the sum of the other two vectors, like that. So polygon law is simply this only, actually, right? You can just increase the number of sides.
Yeah.
Unit vector you also know how to find, right? Unit vector would be A vector upon the magnitude of that vector. Okay.
Students practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.